Creating linear regression models. In Algebra 1, you learned how to find and write the equation for the line of best fit by hand. Well, graphing calculators have the ability to make a more precise line of best fit by finding what's called the linear regression of the data. It is a linear model that establishes the relationship between a dependent variable y and one independent variable x. The calculator can also compute the correlation coefficient. The sign of this number corresponds to the behavior of the data. In other words, if it's positive, the data rises from left to right, and if it's negative, the data falls from left to right. And this number also tells us how closely the equation models the data. The closer the correlation coefficient is to +1 or -1, the more closely the equation models the data. The calculator that we're going to be using within this topic is a TI-84 Plus calculator. Let's get started. The table shows the number of goals of the leading scorers for an ice hockey team. So in 2010, 33 goals were scored, 2011, 38 goals, 2012, 45 goals, and so on with the data that shows in the table. Let X be the number of years since 2010. Create the equation for the line of best fit for the data, and then find and interpret the correlation coefficient, and round all decimals to the nearest 10,000ths place. Before we begin solving this problem, we need to make sure that the stat diagnostics are on. To do so, press the Mode button, and then scroll down to the stat diagnostics line and make sure that the setting is set to on. If it is originally off, scroll to the right until on starts to blink and then press the enter button. And once you're done, you press second mode in order to quit back out and return to the main screen. To start solving this problem, we then have to press the stat button, which brings us to this menu, and we're going to select edit for edit the lists options that are available, and then press enter. Next, we're going to enter the data in each of the list columns that show up in the calculator. So for list 1, we're going to have it be the years, and we'll assign the year 2010 to be 0 since it ends in a 0. And then 2011 would be 1, 2012 would be 2, 2013 would be 3, and so on. And then list 2 will be all of the goals that correspond to each individual year that's provided in the table. Once the lists are entered, you can create the regression by pressing the Stat button and then selecting the Calc option, which is the middle heading, and then scrolling down or pressing option 8, Linear Regression, LinReg for short, with A plus BX in parentheses. And once you get to that menu, if you scroll down, you would press Enter. The next screen that pops up tells you or allows you to assign the X variables to a list and the Y variables to a list. By default, L1 shows up for X and L2 shows up for Y. Since these do correlate with the data that we entered, we can just scroll to the bottom of the screen and press Enter. Now, this is a lot of information that they provide on one screen. They begin with Y equals A plus BX, and then they tell you what A and B are. They say that A is 36.5 and that B is 1.821428,571. And since we're rounding to the nearest 10,000ths, that would be the fourth decimal place, we would still have A, which turns out to be our y-intercept, to be 36.5, and our slope, or B, is 1 and 8,214 10,000ths. And then we have the X after it, because that represents the slope of our line. If you wanted, because in addition the order doesn't matter, you could switch around and put the slope with the X first, and then put your y-intercept second. But both of these linear equations are acceptable answers. So we found the equation of the line of best fit. So now we have to find and interpret the correlation coefficient. Well, the correlation coefficient is the bottom number within the linear regression data that was provided to us, and it is 7,803/10,000ths, which means that the equation models the data fairly well since it is close to 1 or -1. Sometimes you'll get a correlation coefficient that's negative, and if it's closer to -1 in that sense, then it also models the data fairly well.